This system is not steady. From a distance, it only looks steady. But look closer, and you see the strain. Air is moving more earth than before. The frame has shifted. When dust forecasts predict a major plume, hospitals anticipate a surge in respiratory cases and adjust staffing. Power grids plan for reduced solar generation and increased demand from air conditioning, bringing reserve power online. Grids adapt. Airports face delays as visibility drops. Trade slows. Changes that once stretched over ages now compress into seasons, sometimes weeks. Not over centuries, but within working lifetimes. The first changes are subtle. The later ones are not. By the end, the world functions differently. We will follow the chain. The air has thickened. Since the 1850s, atmospheric desert dust has risen by roughly 50%. It changes daylight color, softens shadows, and dims the sun to a pale disk. It enters lungs as PM10 and PM2.5, raising respiratory and cardiovascular risk. Over 80% of airborne dust originates from North Africa and the Middle East. A single event in the Sahel can transport millions of tons of mineral aerosols across the Atlantic. This dust provides vital phosphorus to the Amazon basin, but it also degrades air quality for millions in the Caribbean and the Americas, altering weather patterns along the way. Preparation becomes routine. Households run air purifiers and seal windows. Schools monitor air quality indices to cancel outdoor sports. Clinics stock up on respiratory medications before a dust event arrives. Each year, around 2,000 million tons of dust lift skyward. A budget that shades light, seeds clouds, and strains systems. More than 150 countries feel the impact. The chain is global, connecting our planet's geology to our own biology. How does this shifting baseline affect your part of the world? The first signs are subtle, painted across the sky. A dustier atmosphere turns the familiar blue to a milky, opaque white. Mornings and evenings burn with an intense, almost unnatural red and orange as the suspended particles scatter away the shorter wavelengths of light. By midday, the world feels different. Daylight is dimmer, more diffuse, as if seen through a filter. Shadows lose their sharp edges. While surfaces on the ground heat less, the air aloft can warm instead, creating strange thermal layers in the atmosphere. At night, the cosmos vanishes. The same particles reflect city light back toward the ground, amplifying urban sky glow and washing out the faint, distant tapestry of the stars. But the consequences are more than just aesthetic. They are felt in our bodies. During heavy dust days, emergency department visits spike for asthma, COPD exacerbations, and acute cardiac stress. The smallest particles, PM10, and the even more dangerous PM2.5, slip past our natural defenses. They lodge deep in the alveoli of the lungs and can even cross into the bloodstream, triggering systemic inflammation. Across entire regions, the public health load accumulates. A persistent cough, a constant wheeze, a struggle for breath. On the dustiest days, mortality rates from respiratory and cardiovascular causes tick demonstrably upward. The natural world suffers a parallel assault. Wind-driven grit acts like sandpaper, shredding delicate leaves, scarring stems, and physically interrupting the vital process of pollination. What isn't shredded is suffocated. Thick layers of dust settle on foliage, blocking sunlight and clogging stomata. This reduces photosynthesis, effectively starving the plant, slowing its growth, and lowering crop yields. A single heavy dust event at a critical point in the growing season can cut harvests by a quarter or more, turning a farmer's thin profit margin into a devastating loss. Our infrastructure is just as vulnerable. On solar panels, even a thin, almost invisible film of dust can significantly trim electricity generation. Regional storms can trigger sudden, widespread power deficits as entire solar farms go dim. Grid operators are forced to fill these gaps, often by firing up expensive and carbon-intensive backup supplies. This raises both consumer costs and emissions, undermining the very promise of clean energy. Aviation slows to a crawl under near-zero visibility, causing cascading delays. Meanwhile, jet engines ingest abrasive mineral particles that erode components and can glaze hot turbine parts, demanding costly, premature maintenance. In the face of this, a playbook for preparation is emerging. Households learn to seal windows and run air purifiers. Schools prepare to move recess indoors and monitor at-risk students. Clinics plan for surges in respiratory cases. Airports reschedule flights and protect grounded aircraft. Power grids use dust forecasts to anticipate solar dips and ready their reserves. This is systems thinking in action, a coordinated defense against a shared threat. The economic toll is staggering. In parts of the Middle East and North Africa, annual losses from dust and sandstorms are estimated to exceed 2.5% of GDP, a constant drag on growth. For households, the costs are direct: medical bills, lost wages from missed work, and the expense of filtration systems. For firms, it's a story of operational downtime, damaged equipment, and increased maintenance budgets. And these impacts are not confined by borders. Every year, hundreds of millions of tons of dust from the Sahel travel across the Atlantic. This massive plume fertilizes the Amazon rainforest with phosphorus, but it also seeds hurricanes, affects air quality in the Caribbean and the Americas, and can even transport harmful microbes. This global flow reveals a profound truth. Dust is not just a local nuisance, but a planetary connector, coupling distant ecosystems, economies, and our collective health in a complex, delicate, and increasingly fragile balance. Mineral dust reflects sunlight, cooling the surface while warming the layer where particles float. As cloud seeds, dust alters droplet number, brightness, lifespan, and precipitation patterns. Some clouds brighten and cool. Others trap infrared and warm. Iron, phosphorus, and nitrogen ride dust to nutrient-poor waters. Blooms expand, drawing CO2 into the ocean's biological pump. Benefit or risk depends on context. Food webs shift. Harmful blooms can emerge. Deforestation, overgrazing, and drought expose soils to wind, amplifying emissions. Restored cover slows wind, traps sediment, and cuts the source at the root. A roughly 50 to 55% rise since the 1800s reframes climate sensitivity estimates. Global welfare losses approach trillions annually when health, transport, agriculture, and energy are tallied. Dust slows logistics, raises inventory buffers, and erodes just-in-time efficiency. In arid belts, frequent panel cleaning and water use raise renewable OPEX and local water stress. Firms face higher premiums, maintenance, and absenteeism costs that compress margins. Public budgets tilt toward acute care and emergency response, crowding out long-term investment. Land use choices upstream impose costs downstream. The externality crosses borders and oceans. Soiling reduces irradiance on cells and elevates mismatch losses across arrays. Operators commit reserves, increasing system costs and emissions intensity. Silicate particles can partially melt in turbines, forming glassy deposits that degrade efficiency. Dust reduces visibility and tire grip, raising crash risk and triggering closures. Tracks can be buried, requiring heavy equipment and reroutes that delay freight. Marine operations pause under low visibility. The ripple spreads from quay to warehouse to retail shelf. Children and elders carry higher risk. Outdoor workers spend more hours in exposure. Low-income communities lack sealed housing and quality filtration, turning storms into emergencies. Surges overwhelm clinics, delaying care and worsening outcomes. Crop failures push migration from drylands to cities already under pressure. Then the wind calms. Dust settles. The cycle waits for the next gust. Dust shifts clouds and rain, shifts yields and prices, shifts household budgets and national stability. It fertilizes seas, alters carbon uptake, feeds back into temperature and circulation. It grounds planes while grids scramble. Two systems stressed by one plume. Health, energy, water, and trade metrics move together in new patterns. Intervening in one node can stress another. Systems thinking is no longer optional. In this emerging dust age, rising dust has slightly cooled the surface, concealing a fraction of greenhouse warming. But this is a fragile shield. If the dust mask thins, whether through climate shifts or our own actions, latent warming could surface faster than expected. Better land management offers a dual benefit. It can cut emissions and begin to remove that very mask. Dryland restoration, strategic windbreaks, cover crops, and managed grazing are proven methods that keep soil grounded and productive. The challenge is global. Dust from the Arabian Peninsula regularly travels over 1,500 miles to impact air quality and monsoon patterns in South Asia. This reality demands a new preparation playbook. Accurate forecasts are the first step, turning surprise into readiness. For clinics, this means scheduling extra respiratory staff. For grids, it means anticipating solar power dips and readying reserves. For airports, it means adjusting flight schedules to protect engines and ensure safety. At home and in schools, sealed buildings and HEPA filtration become essential tools to protect indoor air, where people recover, learn, and sleep. On our infrastructure, robotic dry cleaning for solar arrays reduces water stress and keeps renewable output steady. Regional agreements are now aligning land, water, and health policies across these vast dust corridors. The UN's Decade on Combating Sand and Dust Storms marks a critical pivot from awareness to coordinated cross-border action. Each investment now pays dividends forward: fewer hospitalizations, steadier power, and more resilient harvests for a world learning to manage its dust. We have learned that dust cools and warms, nourishes and harms, reveals and hides. A single plume can shift clouds, power, markets, and lungs, quietly, predictably, repeatedly. The world remains functional, yet altered. The chain continues. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.